So we're going to try that again. We're going to use that idea again, but now in a more kind of like practical application scenario. We have this diagram, and it's showing this situation. A plane takes off and climbs at a 12-degree angle. So it left the runway right here, and it's going upward at this 12-degree angle. Question is that angle sufficient enough to fly over an 11,088-foot mountain that's 12 and a half miles from where the plane took off on the runway? Or does the plane need to increase this angle of ascent to get over this mountain? So you can see we have this right triangle that this problem creates. It creates this right triangle where we have the place where the plane left the runway. We have kind of like the base of the mountain right here, and that's 12 and a half miles away. We need to figure out, is this length right here, which in this point, right, this point, this corner of this triangle would represent the place where the plane is when it gets directly over the mountain, let's say, directly over the place where the mountain is 11,088 feet high. We need to know, is that point far enough off the ground for the plane to clear the mountain, or is it going to smash into the mountain and kill everybody inside the plane? So we're going to find what this x is, but you can see we're going to use the same idea. I'm going to redraw this triangle down here. I'm going to redraw it just without the rest of the picture in there to kind of distract us. So we have a right angle here. We have that this is 12.5. We have that this is 12 degrees, and we want to find x. Now, if I look at my different parts of my triangle, this is the hypotenuse right here. From my 12-degree angle perspective, the 12.5 is the adjacent leg, and the x is the opposite leg. So if I think about the three sine, cosine, and tangent ratios for this picture, it would say that the sine of the 12-degree angle is the opposite over the hypotenuse. The cosine of the 12-degree angle is the adjacent over the hypotenuse. And then the tangent of the 12-degree angle is the opposite over the adjacent. Now, two of these have x in them, but only one of them has all the other information filled out. Only one of these only has one unknown. This one has two unknowns, right? It has x, but it also has this unknown hypotenuse. So I can't really use that. The cosine ratio doesn't involve the x, so I'm going to ignore that one. I'm going to look at the ratio, the equation that uses tangent, because it uses the x, and the x in that problem is the only unknown value. So I'm going to come over here, and I'm going to rewrite that. Tangent of 12 degrees is x divided by 12.5. And I'm going to solve for that x by putting the tangent of 12 over 1 and cross-multiplying. Now the x is multiplied by 1, and the 12.5 is multiplied by tangent of 12. So all I have to do now is grab my calculator, because I know the x times 1 is just going to be an x. I just need to grab my calculator and type out 12.5 times tangent 12. So 12.5 times tangent 12 is equal to about, I should say about there, is equal to about 2.6, let's go with 2.66 miles. And I know this unit would be miles because the 12.5 was in miles. So I don't think I'm ready yet to answer my question, because now I know how many miles above the ground my plane will be when it reaches there, right? This amount is 2.66 miles, but I need to know how many feet above it will be. So the last step I need to do is take 2.66 and multiply by 5,280, which is the number of feet in every mile. So 2.66 times 5,280, and that's going to give me 14,045 about. Okay, it's about 14,045 feet. So to answer my question, it looks like that plane's going to have about 3,000 feet to spare when it's going over that mountain. It's going to be kind of close. I guess 3,000 feet doesn't sound like it'd be all that close, but I think if I was sitting in that plane and I looked down and I saw a mountain 3,000 feet below me, it might seem pretty close. But nonetheless, technically, it would have enough altitude to clear that mountain. It doesn't need to, the pilot doesn't need to change the ascent, the degrees of ascent of the plane. I think it'll clear. Okay, now in this last example, you'll notice that we have a right triangle, and we know two sides of the right triangle, but what we're supposed to find is how many degrees this angle is. Now, if I just told you how many degrees this is, that would be easy, right? You could just take this 90 minus whatever this one is, and that would be this angle right here. But I don't have that. All I have is side lengths for this. I have two side lengths for this right triangle. Technically, I could find the third side using the Pythagorean theorem, so I guess I kind of know all three sides. If I really wanted to, I would know all three sides of this right triangle. And what we're going to learn in this problem is how we can use sine, cosine, and tangent to find the angle measure that's missing here, so long as I know two of the sides of the triangle. Okay? If you remember back to one of the previous problems we did in this section, I said that the sine and the cosine and the tangent are like the fingerprints for every angle, right? Every acute angle specifically has a very specific set of values for sine, cosine, and tangent. The sine, cosine, and tangent of a 21-degree angle is slightly different than the sine, cosine, or tangent for a 22-degree angle, slightly different for a 20-degree angle. Every specific angle measurement has very specific values for sine, cosine, and tangent. And I always describe it this way. It's kind of like if I was investigating a crime scene and I found a fingerprint at the crime scene, I could perhaps trace that fingerprint back to see who it belonged to, right? Crime scene investigators have those databases that they can use to find, hey, here's this fingerprint, let's see if I can trace this back and match it to the person that it belongs to, because the idea is every person has very unique fingerprints. Angles are the same. If I have a fingerprint for this angle, a sine or a cosine or a tangent value for that angle, I can trace that fingerprint back and see what angle value has that particular fingerprint. So let's look at what we can say about angle y. First, I'm going, or the angle that has y degree measurement. I'm going to label the parts of my triangle. I know that this side here is the hypotenuse. From the perspective of the y degree angle, this is over here, this 14 is the opposite leg, and this 30 is the adjacent leg. So now I think about SOHCAHTOA, and I ask myself, which of these three fingerprints do I have for this angle? Do I have the sine fingerprint? Do I know what opposite divided by hypotenuse is? No, because it's 14 divided by something that I don't know. So I don't have its sine fingerprint. Do I have its cosine fingerprint? Do I know what adjacent divided by hypotenuse is? No, because it's 30 divided by something I don't know. That's what its cosine would be, right? 30 divided by this. But since I don't know that, I don't actually have its fingerprint for cosine. How about tangent? Tangent would be opposite divided by adjacent, and I know both of those values. So I have a fingerprint for this y degree angle. I have its tangent fingerprint. Let me write out what I mean. I know that the tangent of my y degree angle is 14 divided by 30. 14 divided by 30, we could look at that as 7 over 15, or we could look at that as being 0.46 repeating if I turned it into a decimal. There is only one angle, one acute angle, that has this value for its tangent. It has this fingerprint. And so we're going to use our calculator to find it. And then the function that we use is actually the secondary function for the tangent. It's called tangent inverse. You can see right there on your calculator, it'll say tangent to the -1 exponent. -1 is shorthand for saying inverse. So that's called the inverse of the tangent function. And the way the inverse function works is I put in a value and it reports back to me what angle would have that value for that trig ratio, whether it's tangent or if I use inverse cosine or if I use inverse sine. So I'm going to type in my calculator, I'm going to type in the tangent inverse of 7/15, 7 over 15. And that's going to give me the value for angle y. So I'm going to grab my calculator, I'm going to hit second tangent, 7 over 15, and I'm going to close the parentheses. Always remember that when you open or when you press sine, cosine, or tangent, it opens a parentheses automatically. Close that parentheses when you're done typing what you want it to be in there. So like the way I wrote it with the parentheses around 7 over 15, when I hit tangent inverse, when I hit second tangent, it opened this parentheses. I'm typing in 7 divided by 15, and I'm closing that parentheses, and I'm going to hit equals. And it tells me that the measure of angle y, or the value for y, is going to be about 25.0 degrees. So that angle there must be an angle that's about 25 degrees based on what its fingerprint is.